Hi class, today we're going to be looking at section 10.1.4. How can I measure variability? Standard deviation. So we've been talking and kind of leading up to this idea that it's not enough that we have like the some low scores like in terms of the when we tossing for the golf game, we wanted to not just have the low scores, but also have consistently low scores. So we want to, first of all, try and look at a situation where it really makes it clear that we need to have this measurement called standard deviation. And then we're going to talk about how to compute it. So question 60 is, why do we need standard deviation? So a biologist is trying to determine which sugar is more successful in growing a particular eukaryotic cell. So here's a cell and they need sugar to grow. She collected the data below, and these are the diameter in micrometers. So some of them were fed sugar W and some were fed sugar P, and you can see based on the sugar there's difference in sizes. So what I want you to do first of all is create a combination histogram and box plot for each sugar, and it says use an interval of 10 to 80. So we're going to start at 10 and go all the way up to 80 for our histogram. Um, and we're going to use a bin width of 10. So from 10 to 20 will be one bin. Remember, we start at 10, we go up to, but don't include 20. So 20 goes into the next bin up. So, and then we're from 20 to 30, 30 to 40, etc. So again, this is kind of an idea right here. This is what a histogram looks like when we're producing that for sugar W and then for sugar P. Once we've got our bin set up and we've counted how many sugars go in each particular bin, then we need to just scale this up appropriately and draw the bars in for the histogram. Right below that, there's enough room for you to also include a nice little box plot so we can see the minimum Q1, the uh, the median Q3, and the maximum value. So, and again, that's up here. We're going to do a different, we're going to put the histogram on top and the box plot down below there. So that's question 60. Also on 60, you're asked to calculate both the mean and median of both collections of data. So what's the mean, what's the median? Um, Discuss that with your group. You should be able to figure out what those two are. We've talked about them. If you need to, you can use the glossary in the textbook. It definitely has those listed. The two sets of data are obviously not the same. Well, you're going to have to read this and think about this question in context of what results you get up here. So we're just going to move past that. Um, the next thing that you're going to have to do is we'll move on to this measuring spread. In problem 1060, you saw that in addition to the typical value, it's also important sometimes to know something about the spread of the set of data. So how how much does it move away from what's typical? One way to measure the spread of data is called the range, and that's just the maximum value in the data set minus the minimum. What range of cells sizes did each sugar grow? Why is the range often not useful as a measure of spread? So you might want to look at that. And for both sugar W and sugar P, what's the range of each one of those? I'll be looking for your responses here. And then finally, when the data is not symmetric or it has outliers, the interquartile range can be used to measure spread. Compare the IQR, the interquartile range, of two sugars. If you need a reminder, you can look up that in the math notes from lesson 10.1.2 in your textbook. And then we're going to talk about standard deviation here. This is a little verbose, so I want to go over this with you. The standard deviation is yet another measure of how much variability spread out the data in a set is. Standard deviation is the average of all the distances to the mean, and then this gets verbose, after the distances have been made positive by squaring them. So literally you're finding out how far each individual value is from the mean, then you're squaring those differences. Then you calculate the average of the squared distances, and then you take the square root of that. It's a lot of calculations, and I'm not going to ask you to do that. For a large data set, for sure, we may talk about it and do it with a very small one in class just so we can see exactly what's happening. If the data has outliers, or it is not symmetric, the standard deviation should not be calculated and used to describe spread because the standard deviation is based on the mean. The mean may not be representative of the center if the data was not symmetric or if it had outliers. Right? So if you have a data set that's skewed one way or it's got outliers, what happens is the mean and the median are pulled away from each other. So the mean may not be the best description of what the center of the data is. And again, standard deviation is measuring how far the data is the average distance from the mean. So in this case, the interquartile range should have been used instead. Question 63, I'd like for you to calculate the standard deviation for your team's tosses from the 40 holes of golf event. Actually, I just want you to do that with just one of the 10 values that you had, not the entire team set, just one. Um, and if you look down below here, well, the standard deviation was probably not an appropriate way to report the spread of your team's golfing data. Why or why not? In order to do 63, I actually want you to use the calculator. So there's a video attached with question 65 by itself. It says your teacher will demonstrate how to determine the standard deviation using your calculator. Verify the standard deviation for the two sugars in the problem above. But I also want you to use this technique to do this for your 10 values. So pick one, what you think is one of the best represented, just the best person that you think that was in your group. Calculate their standard deviation for their 10 values. Answer question 64. Think about this. Um, think about it in terms of why you may not want to use it, what could have been better, and what we've read up above. Um, and then do this 65 for both sugar W and sugar P. So right here, I'm going to put another QR code that you can scan and watch a video where I talk about how to use your calculator to calculate the standard deviation. And then you guys can flip to your homework. Okay, I'll see you on Monday.